everyone, I'm Alec Kaluza, and this is my presentation on Lab 2 for Physics 2212. To begin, I'm going to introduce the purpose of the lab, some essential ideas used, and some of the preliminary results that I obtained. The purpose of the lab is to obtain a more accurate figure for the U-tape charge that we found in Lab 1 with the hanging tape experiment. This time we are dividing the tape into point charges rather than treating the U-tape itself as a point charge. Some essential ideas used are Coulomb's law, the idea of superposition, some of Newton's laws, and the idea of electric fields of distributed charges. The preliminary result I obtained was that the charge of the top U-tape was 3.66 times 10 to the negative 18th coulombs. How this presentation will look is I will give an overview of my Lab 1 results, move into some key assumptions made to obtain the results for this lab, and then go over some of the code. To begin my Lab 1 overview, the data I obtained from that lab was the length of my tape was 0.206 meters, the mass of that tape was 2.06 times 10 to the negative 4 kilograms. The distance between the two tapes at the point of repelling was 0.015 meters, or 1.5 centimeters, and the gravitational force of the top tape was 2.02 times 10 to the negative 3 newtons. The result I obtained in Lab 1 was that the U-tape top charge was 7.1 times 10 to the negative 9 coulombs. And some key assumptions for this lab. We are meant to ignore air resistance on the hanging tape. And then the U-tape also, we had to assume that it has a uniformly distributed charge. So, moving into the next point, we can consider each individual segment of tape as a point charge with equal charge. And lastly, we have to ignore interactions within each tape and the point charges of each tape. The only interactions we are looking at is the interactions between a point charge on the top tape and the bottom tape, and vice versa. So no interactions between a point charge in the top tape with another charge in the top tape. Here's a link for the code for whoever's watching this. Feel free to pause. The code link should be in the description as well. To begin, I'm going to go over my electric field function and then how the line charges were created. For the electric field function, I simply obtained the charge by taking the charge particle charge, and then found our R vector by subtracting the position of the charge particle from our observation location. I then calculated the magnitude of R and R hat, as we have learned in class, and then used the electric field formula for such a scenario and returned that. For the line charge, we can see that there is an array which we then fill with point charges using the sphere. And we are able to modify certain things here, such as the mass, color, and n, which I will talk about in the next slide. Here's my code for the two tapes. I ensured that the top tape was at the position I recorded in Lab 1, so 0.015 meters above the bottom tape, situated at the origin. And then I changed I changed the n in both tapes here to 100 in the hopes that I would be able to get a more accurate result from this model. I didn't modify the colors at all. Then here in the last part of my code, we can see I changed some of the scales to make the model more visible. Here we have the nested for loop, where we are calculating the electric field due to every point charge in the bottom tape on every individual point charge in the top tape, and calculating the net of every electric field at every top point charge for our final electric field, and then the force, which can be seen here in the model, that the magnitude of the electric force and gravitational force are equal. And here the force is shown by the white arrow, yellow arrow is gravitational force, and green is the electric field on each individual particle charge in the top tape. The top tape is red and bottom tape is blue. Like I said, I didn't change these colors. I thought they worked just fine. To answer the final questions, what if I had modeled each of my tapes as a single point charge like in Lab 1? To compare the results, my previous lab found that the charge was 7.1 times 10 to the negative 9, whereas this one found that it was 3.66 times 10 to the negative 18, which is almost a negative 100% change. So these estimates differ because being able to split the tape into multiple point charges allows us to obtain a more accurate result as to what the charge actually is, because we are not assuming that all the charge is located on one spot of a 20 centimeter long tape. We're able to divide it, see maybe how it's distributed a little bit, and come to a more accurate result. And that's why this lab, I feel, gives us a closer result to the real value of the charge. Thanks for listening.